Welcome to the initialization of the WUT testbed. Before proceeding to the initialization, we would like to remind you the implementation architecture. We deploy 6G-Cloud framework as a set of containerized applications over a virtualized infrastructure. To run the system components, we use Docker Compose. First, we deploy the CCF supporting services, which include databases, MongoDB, and MinIO, serving as the NS Requirements Database, NSRD, Global Topology Database, GTD, Resource Partition Database, RPD, and Resource Partition Assets Database, Message Broker, Kafka, with a Kafka UI CAFBAT, and monitoring tools, InfluxDB and Telegraph for data center monitoring. Once the services are up, the init containers are started. These connect to CCF and MOF databases to populate them with the configuration data that will be used in later stages of the demo. Next, the core components are started. Resource Partition Creation Engine, RPC, Resource Partition Requester, RPR, and Service Orchestrator. RPC and RPR connect to the Kafka message bus, and all components verify their connectivity to the corresponding databases. The data can be inspected with additional tools. For MongoDB, MongoDB Compass is used. Two separate databases are created for MOF and CCF, with collections corresponding to NSRD, GTD, and RPD. So far, the databases contain the DC topology information and requirements for the network service of type test that will be orchestrated during this demo. The collections containing currently created recipe partitions and orchestrated network services remain empty and will be filled in the course of the scenario. Resource partition assets can be accessed directly through the MinIO UI. Upon logging in, all existing data buckets are displayed, including the resource partition bucket, which contains the network services asset bundles. Within this bucket, there is a test folder containing resources for the network services of type test, which will be orchestrated in the next part of the demo. The test bundle comprises Ansible playbooks for cluster creation, establishing Cilium service mesh for multi-cluster communication between pods, Karmata control plane setup, and installation of resource partition toolset. It also contains Terraform templates for infrastructure provisioning and establishing connectivity. The resource partition assets are cached by RPC in runtime and mutated during resource partition creation or update. The modifications are based on the resource partition graph, which is derived from the network service-specific requirements and optimization goals. Communication over the message bus can be inspected using CAFBAT. It displays the topics created by the components and messages published by 6G-Cloud components during the operation. To sum up, this setup ensures that all components are connected, the databases are populated, and the resources are ready for resource partition and network service orchestration using the 6G-Cloud framework. We invite you to explore further parts of the demo. Links are available in the description.